All right, here are some examples of trying to solve systems of equations. Many different ways you can go about these. Because these all have squared terms in them, the easiest thing to do is like, since you have x squared here and x squared here, take one of these two equations and solve it for x. And so we're going to take the second one and solve it for x. And so we're going to subtract 4y and we'll go to negative x squared equals negative 4y minus 10. And the next thing we would do to get rid of x by itself is multiply it by a negative 1. So we get x squared equals 4y plus 20. So now since x squared equals this one can be substituted into the other equation. So x squared, taking this part out, substitute that in the 4y plus 20 plus 4y squared is 100. Now then, because we have both y squared and y, this is a quadratic equation, so we have to get everything to one side and get it in the proper form. Subtract 100, so we'll do that second way, so it's 4y squared plus 4y minus 80 equals 12. Then you have to kind of find the roots. Y equals 20, you can factor it out everything by 4. Y squared plus 5 minus 20 equals 0. And factor this. Factor the negative 20 and add up to a positive 1 would be y plus 5 y minus 4. And if you set each of these equal to 0, y equals 0, 4 equals 0, in this case y equals negative 5, this is y equals positive 4. Now, in this particular question, they only wanted a solution that was in quadrant 1. Okay, quadrant 1 is this quadrant here, where both your x and y values are positive. So therefore, you would not have to do anything with this if the y value is negative. So now we know that y has to be a positive 4. Now, having not said that, then this part here, then you have to find all the different answers, so you don't have to find everything. Here it is, so y equals 4. Now we go back to one of the two particular problems, or you can even use this equation right here, or one of the two originals, and you substitute y into the equation. In this case, I'm going to use this substitute y into x squared equals 4y plus 20. So x squared equals 4y plus 20. So now I substitute a 4 in, x squared equals 4 times 4 plus 20. X squared equals 36. And taking the square root of this, let's see, x equals both a positive 6 and a negative 6. Because anytime you take the square root of something in the equation, x can be either one of those two things, because if you have 6 squared, you get 36, and if you have a negative 6 squared, you get 36. So x is either 6 or negative 6. So then y is 4. So we know that one of the coordinates is 6, 4. We also know another one is a negative 6, 4. And those are two solutions. Now, so it had to be in quadrant 1. This is what the solution that's in quadrant 1. That solution was in quadrant 2. And if you wanted to, you would substitute a negative 5 in for y. So you have to do times on all. square root of 4 squared times a negative 5 plus 20. 4 times negative 5 plus 20, so that's x squared equals 0. And when you take the square root of that, you would get x equals 0. So then the only other coordinate is negative 5, 0. And so this particular set of problems, this particular set of equations has 3 solutions. 1, 2, 3. Now what that means is, this thing right here, since it's x squared plus 4y squared equals 100, that's an ellipse. I don't think it looks like this. Here we have 4y minus x squared equals a negative 20. That is a parabola. It's a whole square term. So the parabola probably does something like this. And there's a coordinate, and there's an intersection point, and there's an intersection point. And one of those is at 6, 4, like this one. Another one's a negative 6, 4. And another one is at negative 5, 0. So I don't have to draw it right, but you hopefully understand that it's drawing in 3 places. Okay, then moving on to another one here, we have 2x squared plus y squared equals 3, and then x squared plus y squared plus 2y equals 17. So, doesn't matter again, pick one of the equations, solve it for one of the variables. Now in this case I would not take this and solve this one for x instead, or x squared even. I would take one of the other ones, and so I don't have to do too much work, so I'm going to take that one and solve for it. I have to subtract 2x squared from both sides, so then you get y squared equals negative 2x squared plus 33. Alright, and so now since I know that, take this part and get 4y squared x squared minus 2x squared plus 33 plus 2y equals 18. And then because it's a quadratic equation, put it on one side. And don't want to do that though. Y. Because now we have x squared and x squared, it has to still have a y. So that was a bad choice on my part, so let's back up. So we can't have 2 different variables in the equation and solve for it. So let's take this equation and solve it for x squared. So if we're going to solve that for x squared, take either one of these two and solve for x squared. But if you take this one and solve it for x squared, then you have to divide by 2 and make it a fraction. Just have to all by itself, so you don't have to worry about it. So you just have to subtract y squared and subtract 2y. So that's x squared equals y squared minus 2y plus 15. So once that gets put in, so equation, this thing, just go right there. So this is y squared minus 2y plus 19 plus y squared equals 33. And solve this, get it all to one side. First, 2y squared minus 4y plus 38 plus y squared minus 33. 0. Simplifying it. And then this is y squared. No. Either y squared. Like that and that. And 4y plus y equals 0. And just because this whole equation by -1, y squared plus 4y inside equals 0. And next thing we need to factor, and the factors of a -5 that add up to 4 is the positive side of a -1. And in this case, -5, and in this case, y is 5.
It was fine, but I'm just going like, oh my gosh,